Welcome to the Cosmos Safari podcast. In this episode, my co-host Rob Webb, the last-minute astronomer, and I discuss the mission, travels, and current state of the OSIRIS-REx sample return mission to the asteroid Bennu. As of this recording, the asteroid sample is stuck inside the collection chamber at NASA's Johnson Space Center after a successful return to Earth on September 24th, 2023.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
It's one small step for man, one giant leap for mankind.
All right, well, let's start off with a little trivia here, Dave. I got a couple things, got 3 questions to ask you, and let's see how well you do. Are you ready?
I'm ready.
All right, fantastic. So, talking about OSIRIS-REx, so my first question is, how many missions have been sent to deep space before OSIRIS-REx? Now, that includes flybys, orbiters, missions to any planet. You've got moons or asteroids or dwarf planets or even solar orbit. How many has humanity sent out there?
Okay. So I was actually just on the NASA missions website just a few days ago, and I saw that there are over 650 missions on their missions website, but not all of them are deep space. But it does give me a starting point. I'm gonna go with deep space missions 70.
70. You
70.
are very far off.
Okay.
244.
I was gonna go with half, and then I thought, no, they can't be half the deep space ones. Wow,
Yeah.
200 and how many?
244. I was actually nervous you were going to go above, like go with like 300 or like 400.
I was gonna say half, and of those 650, and I would have been actually a lot closer.
Yep.
And then I don't know why. I just was like, no way. That's crazy. Is that NASA only, or is that
that
inclusive
is
of
humanity.
like other space?
And
Okay.
Russians, Italian, everybody who sent something out. Did the Italians send something? I don't know, but I know I at least saw the U.S. and I saw Russia there. But 244. And that's because I found one of my main sources is this Beyond Earth, a chronicle of deep space exploration. And it was basically from 1958 to 2016. So that number is probably higher in terms of how many we've sent. But this was by Asif A. Siddiqui. I probably didn't do well with the pronunciation. Siddiqui. But it is like I think it's like a 200-some page document PDF that is just amazing. I'll tell you more about it when we get there. All right, number 2.
We could
So
link
you
it
have
in
no
the
points.
description.
Yes, absolutely. Number 2, how many official acronyms are used by NASA?
Oh my gosh.
I looked this up.
Official
And I went through
acronyms.
the official acronyms. I found a list of acronyms that NASA uses, and I think it was on the NASA website, and I basically counted how many acronyms they use.
1,000.
Oh, I'm gonna give you some choices. A,
Okay.
145. B, 239. C, 435. Or D, 1,241.
D, 1,241.
You overcorrected there, sir.
Ah,
You overcorrected. It's 239.
okay.
Yeah.
It seems like a lot more, and they're really creative all the time. So,
Mhm. Yeah, and you know what? I
Now-
bet there are some unofficial ones that everybody uses too. You know?
right. I know that every profession has its own acronyms, but none of them are even close to as cool as the ones that NASA has.
Right. Right. And we're gonna get
They
into it
really,
because OSIRIS-REx is like a lot of them, a little bit of a stretch, but they worked hard and they got something good. I like it. All right, let me give you a last one here. Okay. What would the acronym for a mission to a black hole be? A. Spaghetti. Spaghettification Research and Exploration Initiative. B, holographic illumination, aka hyperdimensional observation and light-based investigation of gravitational effects and events. 3, or C, I forget what I was doing. Noodle. I like this one. No optimum delayed escape. Spaghettification was too long to actually make into an acronym. But I've got 2 more. Lucifer. Light's unraveling of cosmic intrastellar fractures and emergent radiations. Or E, IDKAAA. For, I don't know, acronyms are annoying.
I like the first one.
Spaghetti?
Spaghetti.
Yeah, I like spaghetti too. It kind of has that Italian flair to it. And you just,
Yes.
Spaghettification Research and Exploration Initiative. Also, bonus question for you. Did I use BARD from Google to make a Cosmos Safari acronym?
Oh, no.
Yes, I did. You don't know what it is, but here's what I figured out. It is Cosmic Observers Sharing Mysteries, Observations, Space Science, Astronomical Facts, and Research Insights.
Awesome.
Not bad.
All right, then.
Not bad. There's
I
no
think
way
that
we
should
would
go on
ever
the
use that.
website.
That would be
All right.
terrible.
I'm glad that you're the one making up these trivia questions because these are really cool, and I appreciate the difficulty that I didn't get a single one right.
I am okay. These are terrible. So, but yeah,
All
so
right.
we're here to talk about OSIRIS-REx. And we talked before the podcast. I would take up sort of the beginnings of it, and then you would sort of take it from landing and onward. What's one of the questions that you're thinking of when you think of like, as it's launching or the machinations of it? Like what's the first thing you want to know about a probe like this?
Well, I think it's important that we discuss what its acronym means because, that being our trivia question of the day so far makes me wonder. Now, what is it?
So
what does it mean?
OSIRIS-REx. O is for origins. SI is for spectral interpretation. RI is the resource identification. S is for security. And Rex is for Regolith Explorer. Okay. So there's a lot in there. Let me explain. So the origins.
Let's unpack that. Yeah.
Yeah. The origins is talking about basically they're taking this spacecraft, which I'm going to talk about, and it's going to go to an asteroid. Then it's going to come back, or at least somehow get a sample from this asteroid into our hands. The idea being is that they want to study the nature, history, and the distribution of those materials and other organic material. So we kind of want to know about the beginnings of the solar system, and an asteroid is a really good way to do that.
Hence the origins.
Exactly, origins. And then you've got the spectral interpretation. It's the note that I have here is define the global properties of a primitive carbon-rich asteroid to allow for direct comparison with existing ground-based telescopic data for all asteroids. What that means is, hey, we've been looking at asteroids. We've had this light coming in, splitting it into its rainbow spectrum and analyzing that. Well, is that actually accurate, right? So if we get material from Bennu and actually analyze it, we can see how reliable those methods are.
Ground truthing.
Yeah,
Yep.
Exactly. RI, resource identification, it's talking about mapping the global properties and chemistry and mineralogy of this type of asteroid, right? To talk about its geology, any dynamic history it's had, and kind of give us an idea of, this sample, like a little background information on the sample that we get. Now, the security part, it says to measure the Yarkovsky effect on Bennu and learn which asteroid properties contribute to this effect. Now, I don't know if you're like me, but I'm like, what is the Yarkovsky effect?
I looked this up too. Yes.
All right.
I got into the same rabbit hole.
Oh, I didn't go down the rabbit hole, so you can tell me more about it. But what I have is that it's the force caused by the emission of heat from a rotating asteroid that can change its orbit over time. So what I think I'm getting there, and you tell me if I'm wrong, is because it's rotating and it's unevenly heating, it's going to end up moving its orbit a little bit. Is that right?
That's also what I got. And I watched something from NASA, a little YouTube video clip, that likens it to the heating of asphalt during the daytime, and then the re-radiating of that heat in the hours after sunset. And that radiation is effectively what's providing a small amount of force that then propels, like you said, the asteroid in potentially unknown ways that we know they happen, but we don't know exactly the effect that they're going to have because we're not dealing with a perfectly evenly shaped
Symmetrical.
symmetrical object, and I mean in different albedo, right? So it has different reflectivity. It's got various compositions, so specific heat capacity. There's all sorts of complex things that could be going on here that when you're dealing with a near Earth asteroid like Bennu,
that's where the S for security comes in.
Yeah, let's go into that.
Yeah. Well, I mean, that's this part, right? I mean, we're just trying to make sure that, I mean, we know Newton's laws, right? So we can track asteroids, right? And we can see where they're going to go. And this one, it could hit us at some time. I'm going to save that to the very end. Okay. So let's put a pin in that as far as when it might hit us. But the idea is we're good with Newtonian physics. We're even good with relativity, but the asteroid's not a point mass. It is a chunky thing, right? And those chunky things are going to be uneven and have, you know, different things happen in their orbits that we can't predict. And so that's what this is trying to do, is to help us understand that a little bit more, so that when we are looking at the skies for those NEOs, the near Earth objects, we have a little more accurate reading of its possibility of hitting us. So
right. And then the last part,
Rex, the regolith explorer. You're going to get a little more into this. Basically talking about, hey, let's explore this actual asteroid, the morphology, the geochemistry, and the spectral properties. It's actually kind of all encompassing of the stuff before it, but I think they could have just called it OSIRIS, but OSIRIS-REx sounds even cooler. So, but yeah, so that's what it's trying to do. Let's see. I wanted to,
as a geologist, I have to disagree. The Rex part is necessary.
Why? Tell me why.
Well, I mean, we are getting a sample back to Earth, and that is the kind of unique and important aspect of this mission for NASA, especially given it's the first time that NASA has ever gotten a sample and brought it back to Earth to be studied. The Japanese space organization JAXA, they've done that twice with two missions, Hayabusa and Hayabusa 2. But this is the first time that NASA's been able to do this.
Okay. So so the Rex part is really more the collection and return of the stuff.
Right.
Whereas the rest of it is really more in situ spectroscopy, doing stuff.
And we've done quite a bit of that, but this is the first time we're bringing something back to Earth.
Okay. No, that makes sense. So let's move on to the overall mission, like the whole goal, which we basically went over, but we're going to go to this asteroid and collect about 60.
We have gone to this asteroid.
Yes. So 60-gram sample, bring it back. We've talked all about that. And one of the cool things, I saw a nice infographic that asked how Bennu was chosen. Like, why are we going to this one, right? And so you think there are about over 500,000 asteroids that we know of, right? Then you pare that down to the 7,000 that are near Earth asteroids. And you pare that down to 192 that have good orbits that will allow us to get there and come back. So that's another part of it. Now we have 192 to choose from. Now we need to get something that has a diameter that's bigger than 200 meters. and there are only 26 of those. I don't know why it has to be more than 200 meters. I would think maybe it needs sufficient gravity, or maybe it just that's the size that's probably more likely to get us good science.
I did see something about that, and it has to do with potential landing spots, I think, and just the more surface area to work with. That's what I took away from that.
Yeah, you'll find more flatter spaces. That makes sense.
Right.
Then there were 5 that were carbon rich, because that's more indicative of possible life starting and such. And then they picked Bennu after that. So, and we're talking about an asteroid that is taller than the Empire State Building. So consider the Empire State Building. It's a bit taller and definitely wider, of course. Bigger than the Eiffel Tower. And if you think about it in terms of a person, like the asteroid, think of a person in the Empire State Building. Think of the asteroid. And then this spacecraft is bigger than a human. I'd say it's about the size of a smart car, I think is a fair comparison. Not a Jeep, a smart car that we're sending up there, right? And so, yes, let's talk about that actual spacecraft, all right? So we're talking, it's about 2 tons, a little over 2 tons. It's about, like I said, about the size of a smart car. And it's about 2.4 meters, which is, what would that be like? It's not 8 feet. 8 feet by 8 feet when it's actually stowed in its launch configuration. And you basically have a few pieces of it, right? You've got the spacecraft bus. That's kind of like the structure of it. You've got the TAG-SAM, which is the touch and go sample acquisition mechanism. You've got the sample return capsule. And then you've got all the scientific instruments on there. Okay. And there's a lot going on. I don't want to get into all of that, but that's basically what we're thinking. And this sample return capsule is, I would say, about the size of I guess the bottom half of a person. Kind of looks like a miniature Apollo space capsule in a way. You can look up pictures of the recovery of this thing. And that's the part that actually got the sample and brought it back. It's powered by hydrazine, and there's this like central cylinder in the spacecraft that has all the hydrazine, and that's really what's powering it. It can hold up to 1,245 kilograms of the stuff, which is pretty good, right? It launched on September 8th, 2016. It was on an Atlas V 411 from Cape Canaveral. I looked up the configurations, and what was a little striking, I didn't know that they would do this, but the rocket was set up, and they have different like side boosters they can put on.
Okay.
They only put on one, and they put it on one side. I mean, you kind of have to, but like there wasn't a symmetry to that, and I was a little surprised. I didn't get to go too deeper with that, but that was interesting. There's a Centaur upper stage that's also used in Antares rockets that I've seen launched from Wallops Island. But basically, it goes up. That main booster stage detaches. The fairings come out at that point, I believe. And then the second stage will burn, get it into orbit. And then eventually, I think 3 days in, it got into solar orbit. And then it actually put out these solar arrays so that it could get a lot of energy that way. It's not just hydrazine, but it is the solar power as well. And then 3 days in, it was in its solar orbit going around the sun and just had some thrusters move to sort of adjust it a bit. And then on December 18th, 2016, they had its first deep space maneuver to use the Earth for a gravity assist. And then, yeah, they sharpened its trajectory by changing the velocity by 19 inches per second. Like, there's just a lot of sort of precision in what they're doing.
Right.
I think it's amazing. And then, so a year after the launch, it passed Earth at a range of about 10,000 miles as part of the gravity assist maneuver, and it tilted the orbit of OSIRIS-REx to match Bennu. And then it took some pictures of the Earth and Moon as well, and then it's lined Bennu on its way.
So yeah,
And
the 5 degrees or so I saw is the the asteroid's orbit is about 5 degrees different than the Earth's trip around the sun. So yeah, that's significant enough that you do need to make that adjustment.
yeah,
Um, Very cool. Yeah, so
yeah,
I would love to look more into the rocket tree at some other point,
yeah,
with other future missions, but I've never, I don't think, seen something that was imbalanced. That's kind of interesting. Very
yeah.
cool. All right.
So what do you got then? So we've sent it. Tell me what it found. What did it do? What happened when it got there?
Okay. So you know, the main thing that was kind of surprising to me is that, it arrived uh and it sat in orbit around Bennu for quite a while. It did this so that they could map the surface and, really determine where they wanted to take the sample from. And what they were looking for is nice, flat, even ground that they could easily go down without, potentially damaging the spacecraft. Um, to their surprise, the surface is a boulder field. And not only is it a boulder field, they later found out, once they had made the actual attempt and successful attempt at that, to collect a sample, that it has the consistency of a ball pit. And
Oh,
if you were to jump in, you would have very hard time getting back out. It's very loose material, a lot of voids in the different little rocks
oh,
and such that make up its surface. And this
that's
was
cool.
not known. And fortunately, the plan was to do a quick touchdown. It was only about 6 seconds where they were doing the sample. So the sample arm went down, it touched the surface. They used a nitrogen gas to blow material into the area where the collection chamber was.
Mm-hmm.
And then they immediately took back off again at about 600 miles per hour. And if it had not been for that decision to exit quickly, it's very possible that the spacecraft could have just like sunk into the surface and been impossible to get back out, which I thought
Oh
was
wow.
wild, you know.
Yeah, you would think they would have. I guess they of course they thought about it, but I wonder why they didn't expect that
It was expected that it was going to be a smooth surface. So the fact that it was boulders in the first place was surprising, but then on top of it, to have it be so loosely compacted, which, when you think about it, there's not a whole lot of gravity there, and the material's just kind of hanging on. The other thing that they thought was kind of interesting was that it was like shedding material. Particles are coming off of off the asteroid, um, before they ever did anything. Like, this was already happening. So it is not a static place. It's constantly in dynamic motion and things are changing, which, coming back to that safety aspect, not only do you have that Yarkovsky effect, you also have, when you have a changing amount of mass, that can affect orbit. That
hmm
can change when you lose a particle. It's equal and opposite reactions too. You're getting all sorts of effects here now that, for a near Earth object like this, it's important to know. And now that we know it, we can use that information to make future predictions and consider these factors that were unknown.
Yeah, that sounds that's incredible. I love how we do know a lot, right? And we can predict a lot. We can send this thing to Bennu, but then like it it still surprises us. Like we still get surprised by what we
Always.
find. And I think
Yep.
that's just a testament to science. And we do know a lot of really good stuff, but there's always going to be a surprise at the end, right? And I want to
Right.
make clear
Right.
too, like it's we get unexpected things, but only at the fringe of what we know. It's not like we're changing the entire way the whole solar system works with what we found. But yeah,
Yep. Um, So I wanted to just dive in a little bit to Bennu itself so that we can get some background understanding of what this object is. So it's estimated to be approximately 4.5 billion years old, which is about 10 million years after the formation of the solar system itself. It's thought that this object was formed. Now, as a result, it represents the building blocks of our solar system, and we think it probably formed somewhere between Mars and Jupiter in the main asteroid belt. The mineralogy and chemistry of it is, in its present day form, pretty much unchanged since that 4.5 billion-year-old beginning. There's not a whole lot that is affecting it in space. So that's important because it's, as we kind of look into this as an object of interest, it's really trying to give us an understanding of where things have come from to create the planets like Earth. And it's thought that the process of accretion, when a planet is being formed, would consist of material like this. And because this is a carbonaceous asteroid, meaning that it contains carbon as one of its primary materials, that's one of the precursors for life. And we can now, hopefully through this sample, have a better understanding of what some of that raw material was that Earth was formed from, and the solar system was formed from, to get a better understanding of what those initial raw materials would have looked like, which is possible in some ways when you can collect a sample of an asteroid, when it impacts the Earth. However, the ability to keep it sanitary goes out the door as soon as it enters the atmosphere. So the big deal here is we have now a sample in hand. It's at the NASA Johnson Center, which contains the vast majority of our non-Earth materials. And it is currently, as of today, still kind of in its container. So they're taking their time. The scientists are taking their time to remove the sealed chamber because it was so successful. The mission was so successful that the original 60-gram goal, they easily passed that. It could hold up to 2,000 grams, which is 2 kilograms. So that's a pretty substantial amount.
That's
60 grams
pounds,
is not much. Right, yeah. Right. 4.4 pounds. And so we're not sure exactly how much we have yet. Some material was outside of the container, and that already has surpassed the amount that we wanted to get total.
Well, now that's tainted though, right? Like if it's outside the, or is it like inside? I think it's like the first level.
Right. I think there's like layers of protection, but I would say it would be less pristine, I would imagine, than what's inside. Okay. So we have some problems where there's some fasteners that are keeping the sample chamber closed that are not coming off easily, and they're working within what they're calling a glove box. And I was like, what do they mean by a glove box?
Yeah, what's that?
And in further looking into it, it's a box that has the ability to put gloves through, right? And so you're working in a sanitary environment. And then on top of it, you're working within the glove box so that you're keeping your germs, your life, here on Earth out of the sample. Because if we want to say, hey, there's potential for life on this thing, if we contaminate it with our own bodies, that's bad. So this is, two very specific glove boxes that were made within a clean room that was made specifically for this mission. So there's a lot of protections that have gone into place. And in the building of the spacecraft, there was sanitary, conditions as well. And they work through all sorts of procedures to ensure that these samples remain pristine as much as we possibly can.
Now, there is a great irony of getting so much material that you can't open it back up, right?
Yes.
Like that blows my mind. Now, the question is, and I don't know if you were able to dig into this. I don't even know if they're releasing this information yet, but why are those things not opening? Like, I know NASA does such a good job. I mean, they have rovers on Mars that last like what, 10 years when they were supposed to last 6 months or something like that. Like, what did you get into anything about why is it not opening?
I think, they could get it open if they wanted to. It's a
Fair
matter
enough.
of they
Doing
are
it
trying their
responsibly.
best. Right, exactly. They're trying to think through every potential problem that could occur. And it really comes down to the ability to keep the sample as pristine as possible. You don't want to
Right.
contaminate it. And you didn't go through all this effort to make a spacecraft that was launched back in 2016, which means, it's been on the drawing board for way longer than that,
Right.
for an extra month, of waiting around to make sure that you do the actual breaking into it, which you're going to have to actually break into this thing now instead of just unscrewing a few things. We want to make sure we're doing it right. And so, what's another month when you've been waiting for decades?
That is fair. That is fair. It's just funny to me that we can't open it up. It's
Yep.
and I know
It
that
is
stuff
ironic.
happens. Like I'm not being like, oh, NASA's terrible, but like it's just kind of like, wow.
Stop
And
being so
again,
successful, right?
yeah, yeah. I mean, that's why it won't open because they have too much stuff, right? So,
Right.
you
Yep.
know,
Yep.
I
So,
think that's super cool.
So OSIRIS-REx, it touched down. It did this touch and go type of procedure. It got more sample, as we've discussed, than was required. It was a major success. They were able to then kind of back off of the asteroid. They did a final flyby back on April 7th of 2021, and it made its way towards Earth.
Oh, wait,
And
wait, wait, wait.
then
Before you go back to Earth, how long didn't it orbit Bennu for like a really long time? Wasn't it like a year or something like that?
so it did the initial touch and go on October 20th, 2020, and then
Okay,
it left, yeah, on April 7th, 2021, to
right.
come towards Earth. So yes, it hung out for quite a while. And,
Yeah,
what the reasoning behind that would be, of course, is that these are not static objects. You wait for the objects' paths, which include the asteroid and the Earth, to kind of get into the natural configuration that takes the least amount of fuel, right? Because
okay.
the next part of this is after the actual spacecraft flew by Earth and dropped the sample, which we now have. It's not over. The mission continues, and it has been renamed to the OSIRIS-REx Apex, where it's the asteroid Apophis rendezvous mission now, where it's yet another near-Earth asteroid. This one will have its closest approach on April 13th of 2029. And for many years after its discovery, there was some major concern that it could potentially be an impactor. We now know that that is not going to be true. However, it will pass, Apophis will pass very close to Earth, 19,000 miles, which is 31,000 kilometers. It will not impact, I'll say that again, it will not impact, but it will get close enough to be a visible object for over 2 billion people on Earth. So if you go outside in the night sky, you have to be in the Eastern Hemisphere. Unfortunately, for those of us who live in the Western Hemisphere, it's going to be an Eastern Hemisphere viewing opportunity when it passes by.
When is that passing by?
April 13th of 2029. So start making
Okay.
your travel plans.
Sure. That's
Where are we going?
it's just amazing of like I get how we know it, but to know that that it's going to be within those hours, right?
Right.
Where nighttime for the Eastern Hemisphere, that's who's going to be able to see it. How big is it going to be in the sky? Can't be that big.
I don't know about size, but it's bright enough that you'll be able to see it naked eye.
Yeah, it'll probably look like a planet or something, I would think, and just be kind of bright and just barely moving along, I would think.
So, yeah, and I haven't really gotten into any detail as to why it's Eastern Hemisphere only. You would think the Earth rotates, and why wouldn't I see it? But that's what was on the website.
I figure they just know exactly, to the hour when it's going to pass by.
And there's
So,
also the sun angle and things like that to be into
Mhm.
consideration. So it's very, very difficult to know exactly why it is, but Eastern
Yeah.
Hemisphere only is what I read.
Okay.
So that's pretty much what I have on that. There are some slight differences between Apophis and the Bennu. So Apophis is a different type of asteroid. It's a chondrite, which makes it a stone and silicon version of an asteroid. It's a different part of the early planetesimals. So the carbonaceous chondrite type is the one that Bennu is, and Apophis is the regular old chondrite.
Okay. So, can you tell me a little bit more about like what's the difference between a carbonaceous chondrite and a stone and silicon chondrite? Like what?
So
Why?
mostly it's the addition of carbon, right? And so carbon is one of the necessary components to life. And so, for that reason, I'm personally interested in this. The fact that it could potentially maybe include some of those precursors that made Earth life possible. There are these things on the surface called chondrules. They look like little spheres that are formed through the the mineralogy of the actual asteroid itself. So they like have some appearances that are slightly different. It's very dark, also in color, which means that in terms of detection, that makes a very, very challenging object to find because it doesn't reflect a lot. It absorbs most of the light that it hits it, and so when you're looking for these objects, it's a challenge. So there could be more of these carbonaceous chondrites out there, potentially even ones that are near-Earth objects that any bit of extra knowledge that we can glean from this mission and, especially, like I said before, with the particles flying off and things like that, it, it really is an important discovery to actually sample this thing now.
Yeah.
My question for you, though, Rob, is what does this mean to you from like not necessarily a scientific standpoint, but just from a like we're living to observe this type of stuff happening in the real world, having the opportunity to watch humanity sample asteroids, to get an understanding of our origins of our solar system. What does that mean to you? How does it make you feel?
To me, it means progress. It feels like we are moving forward. We are understanding more, right? Uh, it it's telling me that my son will have an opportunity to become an aeronautical engineer and work for NASA like he wants to, and he will have something that he can do, something he can work on, to do something cool and find new stuff. I love the exploration part of this. I love the science part of it. I love that we're gonna get more knowledge of how the solar system formed, and it's just gonna make us better. And I'm sure we're gonna get some spin-off technology out off of this too. That's where my mind is. What about you? What does it mean to you in particular?
I think, like you said, progress is definitely something that this mission helps me to kind of see that the future that I hope we have in our lifetime is starting to occur. We will continue to get in more in detail in this kind of stuff on this podcast about, how commercial space flight is starting to take hold, and our understanding of asteroids as a resource, which is part of the mission here, is to understand these things as resources, is going to be essential when we eventually make our way out into the solar system, and we need resources to be able to build things and to survive. And we're seeing the beginnings of that. And also we're providing a level of protection, against these objects that are eventually going to hit. It's a matter of not if, but when. And we have the DART mission, that we haven't talked about on the podcast, but...
Oh, wait. I got a little something about that. So usually at the end, I like to pick out a meme or something and describe it and then talk about like, hey, what are we missing here? Let's go a little bit deeper, right? Well, I don't have a meme for this one. However, I do have, I saw lots of headlines saying asteroid Bennu could hit Earth, causing immense suffering and death. And I was like, okay, that's definitely not the truth. But I was wondering, usually in all of those conspiracy theories or those scary things, there's usually a kernel of truth. And so the reality of the situation is that Bennu, categorized as a near Earth object, which means it will likely pass very close to Earth. So the reality here is that Bennu could pass through what's called a gravitational keyhole in the year 2182. That's a particular spot in space and time. Well, yeah.
I'll be 98 years old. 2182.
No, 2182.
21. So okay, so I'll be 198 years old. Go ahead.
Of course. And just be like a little puddle on the ground or something. And so only if it passes through that keyhole, which, as we said, might happen or might not happen, perhaps because of the thermal, the rotation and the thermal properties. But anyway, right now, the chances of that are 1 in 2,700. That's a 0.037% chance of Bennu actually striking our planet. Right?
So you're telling me there's a chance.
Thank you very much, Jim Carrey. There is a chance. And that's why we're still monitoring it. That's why we're sending this mission out, right? So the asteroid actually passes by Earth every 6 years, and it's had 3 close encounters. One in 1999, one in 2005, one in 2011. And Bennu is expected to pass even closer to the Earth than the Moon in 2135, right? And so if it does, it could strike us on September 24th of 2182. Here's why I'm not worried about that. That makes good headlines, right? Oh, we're possibly going to get hit, and nobody says the actual odds, right? Like Han Solo. And so the thing is that this I'm not worried about, because A, well, I'm not going to be alive. B, we have lots of time, right? And C, we've already tested a tactic to divert an asteroid. And that's what we were talking about before, the DART mission, right? We sent a spacecraft into an asteroid, collided with it, and we confirmed that it actually moved the asteroid's orbit. If we can do that now in 2023, imagine what we can do in 2100 before this even happens. So right. I'm not worried. I'm also not dismissive of it. It's certainly something we need to be careful of and we need to think about. And I'm sure we're going to do other missions besides just impactors. We're going to try to sort of tractor beam them away with gravity. And there's other things out there, but
I'm convinced by that time we're going to have disassembled these things and put use of their materials into building something. Especially if there's not life on it, then we're going to just mine it and it won't even exist anymore. Yeah. We'll have consumed it by then.
Exactly.
As a safety measure, to be quite clear, it would be an interesting thing to preserve, right? Because it's an early piece of our solar system, but at the same time, it also poses a real threat. And so I think like any good predator, we have to eliminate it as humans, so that it poses a threat to us, we've got to eliminate the threat. And so I'm convinced that it'll probably just become like a space station or something. You know, they'll build something out of it.
Yeah, I agree. But I think it's just really cool. I think we're learning more. We're going to protect ourselves better. And we're just going to keep on progressing with this.
All right. So I really look forward to our future podcasts. Thank you, Rob, for all your efforts here in researching this. I hope it was of entertainment for you. And also we've learned something new, which is the goal of it for us here on Cosmos Safari Podcast. This particular episode is made possible by people on our Patreon. So if you would like to help to support this podcast, if this type of information is of interest to you, if you're still listening after all this time, and you're finishing the episode up with us, I just want to thank you for that, and consider heading over to our Patreon so that we can continue to bring this type of really cool science to you as frequently as we can. So thank you again, Rob, and have a great rest of your day.
Yes, please allow Cosmos Safari to be cosmic observers sharing mysteries, observations, space science, astronomical facts, and research insights. Thank you very much, Patreon patrons.
I think we should keep that. That's just too good. All right, Rob.
Took me a while to do the callback, but you know, we got there. Thanks, Dave.
All right. Take care, everybody.